Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics in introduction. We've covered log level and log-log interaction models in detail. There is one more combination worth knowing about, which is the level log model with an interaction. This is less common in practice, but you may encounter it, so let's make sure we cover it very briefly in this video. So the model that we're talking about would look something like y being equal to beta 0 plus beta 1 ln x plus beta 2 z plus beta 3 ln x times z plus an error term. Okay. The key difference again here from the log-log case, which we saw in the previous video, is that now the y variable is no longer logged. So the effect of x on y is a unit effect, not a percentage effect. If we write as usual the marginal effect, we're going to have the derivative of y with respect to ln of x being equal to beta 1 plus beta 3z. So as you can see, not really much changes in here, but in terms of interpretation, what we're going to do now is say that a 1% increase in x is associated with y changing by beta 1 plus beta 3z divided by 100 units. So as you can see, we're linking it to what we have seen in the normal level log model. But now we have the interaction, so it means that the model, like the total effect that we have, is the whole beta 1 plus beta 3z, okay? And as you can see, we have the division by 100. You can look very quickly also at computing the effect with numbers by assuming you estimate a model which is y hat equal to 500 plus 300 ln of x plus 50z plus 100 ln of x plus, times z. And in here, given the derivative of y with respect to ln x, being beta 1 plus beta 3z, this will give us 300 plus 100z. And you can check all the values for z equal to 0, z equal to 1, or 2, maybe it's a better number, and z equal to 5, so that you can really see how by moving with experience your effect and a 1% increase in x is going to raise y by different units. So if you do the computations, you're going to get here that y increases by 3 units, 5 units, and 8 units. If you don't get these numbers, it means you might have done something wrong with the calculations. But otherwise, the unit effect of a percentage change in x grows with the z in here. Keep in mind, when you interpret the beta 3 in here, the beta 3 being equal to the 100 in here, it's telling you the rate at which the effect changes with z, not the effect itself, which is what we have seen overall with all of the models, the interaction models so far. So nothing new, it's just in terms of interpretation, now the y is in units. Why this case is less common? Just because, let's say, in most applied work, when x is logged, most of the times y is also logged, and the log-log interpretation is a bit more intuitive and easier to do. The level log specification is less natural because y is in units while x in percentages, which is something you don't quite see often. Interpretation, as we said, is less intuitive, and most of the times the log-log is just more preferred since you can make the interpretation in terms of elasticities. But that being said, if your data or research question calls for it so that your y is actually either in units, the interpretation will follow exactly the same logic as the other cases. So overall, the main key takeaway from here is that in a level log interaction model, the unit effect of a percentage change in X varies with Z, following the same beta 1 plus beta 3 Z pattern that we have been consistently seeing in interaction models. I hope this was helpful. This covers all 3 log interaction combinations. So stay tuned and I'll see you in the next videos.